All right, chemistry students, I want to talk about mole conversions. And this is where there's kind of sort of three main units, okay? The gram in G, so abbreviated G, and then the mole, which is sort of like your MVP. He's like your big player, which is often abbreviated MOL without the E on it. And the last one is molecule or molecules, which has no abbreviation, strangely. There's no abbreviation for that, so don't get those confused, okay? We're going to go between these, but really you have to have mole. You cannot, it is illegal in chemistry to jump straight from gram to molecule. And just to be clear, the mole is just a quantity that is representing a large amount, so we don't want to write that large amount. There's two main conversion factors that are going to be the players in this, and the first one is molar mass. All right, molar mass has units of grams per mole, but if you're using it, you may have grams on top and mole on the bottom if you're using it as a conversion factor, or you can see it where mole is on top and the unit gram is on the bottom. Now the big number that's like added up from the periodic table values is going to go with the G, and the number 1 is going to go with the mole. Okay? So the number 1 there will be with the mole. The other conversion factor that we've seen is Avogadro's number. Avogadro's number, okay? And that would be 6.022 times 10 to the 23rd. And now here's the part where I said molecule, this molecule option up here could change, because I'm going to say right now particles, because particles can mean more than one choice here. Particles per 1 mole, or once again, if you're using it upside down as a conversion factor, it's 1 mole over 6.022 times 10 to the 23rd particles. Okay, on my exam, the cover page says 6.022 times 10 to the 23rd particles equals 1 mole. Or it's 1 mole equals 6.022 times 10 to the 23rd particles. But that is what you're given. You need to know whether you're going to be using this option up top or this option on the bottom in the actual example. Okay? So we are going to be using either molar mass or Avogadro's number, or both, depending on how big the conversion is. So let's focus in on just the molar mass component. Okay? So we will be going potentially from grams to moles, or we're going to be going from moles back to grams. So my arrow here is not a reaction arrow, it is a conversion specifically with, and then molar mass is sometimes also called molecular weight, formula weight, that kind of thing. Conversion with molar mass. Either direction, grams to moles or moles to grams. Okay? So here would be an example. Let's just pick on water. H2O, just so you can focus on a molecule, okay? So let's say I have 13.84 grams of H2O, and the question, what I want to find, are how many moles is that? So maybe I weighed out 13 grams of water, and I want to know how many moles that is, okay? So I'm going to be doing this option on the left. That's at the top of the screen, okay? So it would just be 13.84 grams of water. Now you would have to solve the molar mass, but it rounds to approximately 18. Okay, what unit has to go down here? Grams, and I'm going to moles, so moles goes on top. So the 18 grams of water to 1 mole of water. So that's that one direction, okay, and that would give you something like 0.77, I'm running out of space, moles of H2O. Don't forget to write your units, okay? So let's do it in the other direction. I'll just pick another color so you can see the other direction. If we were given 0.5 moles of H2O, and the question mark is grams, okay? Well, if that's the case, we start with 0.5 moles, the only given we have. of H2O. Now I'm using the molar mass where the 18 grams is on top and 1 mole is on the bottom. And I don't know what that is. Let me punch it in my calculator. Yeah, 9, okay. 9 grams of H2O. Okay? Just to be clear, you could potentially be given, we're going to go back to black, you could potentially be given, say, 200 milligrams of a substance and asked to find the moles. Okay? So let's just say 200 milligrams of water, and the question mark is moles. You definitely need to know you can't just jump straight into using the molar mass when we've got the milligrams here because it doesn't cancel correctly. So 200 milligrams, this is where it gets bigger. We're going milligrams to grams and then to moles. Okay? So 200 milligrams to grams. So you memorize that. You memorize milli was 10 to the negative 3, which always goes with the base unit, and a 1 goes with the milligram. And then we can do our, if this was water, 18 grams of water, 1 mole. Okay. So into my calculator, I would punch in 200 times, and then my scientific notation, 1 times 10 to the negative 3, I always put in parentheses, and that gives me 0.2, and then I would hit divided by 18, and that gives me 0.011 forever moles of water. Okay? So the next option is the same kind of thing, except we're using Avogadro's number. So we would be going from mole to, and this is where it gets a little annoying because you'd have to spell out molecule, or molecule to mole, okay? And let me make a note, actually, a side note on this. So the particles, 6.022 times 10 to the 23rd particles, that word particles can be molecules, and I'll give an example next to it. So this would be something with a covalent bond, like covalent H2O. It can be formula units, which is sometimes abbreviated FU, okay, which is an ionic substance, like say NaCl. It can be atoms, like atoms of, so you're looking for an element, atoms of plain Jane oxygen, okay, or atoms of chlorine. Okay, it has other units like photons, some other components that you may not see in Chem 1151, but those are the main molecules, formula units, atoms. It's basically things, 6.022 times 10 to the 23rd. So whatever the substance is equals 1 mole of that substance, 1 mole of whatever that thing is. Okay, so let's pretend we are now given the same 0.5 moles of H2O, and the question mark is molecules. I want to know how many molecules of water are hanging out in that beaker that I have of water, okay? So this is one step, 0.5 moles, but we're using Avogadro's number here. Moles is on the bottom. Avogadro's number, by the way, when you're 6.022 times 10 to the 23rd, when you're using it, the number 1 will always go with the mole. So number 1 will always go here. Molecules of H2O. So in my calculator, I'm punching in, I am going to put the 6.022 times 10 to the 23rd in parentheses, and then I'm going to multiply by 0.5, and I should get 3.011 times 10 to the 23rd, and yes, spell out molecules. There's no abbreviation here. Kind of annoying, okay? Going the other direction, once again, we'll change colors. The other direction, let's pretend I'm given 3.25 times 10 to the 21st molecules of H2O, and the question mark is moles, okay? The question mark is moles. So now we're just going in the opposite direction, 3.25 times 10 to the 21st molecules. This is where it differs And students can get confused because, like, if I had atoms of oxygen here, and then you were so used to having Avogadro's number be molecules, and you were like, wait, atoms doesn't cancel with molecules, that's where you start to get confused. That's why I say particles here on the cover page of the exam and stuff. 1 mole. All right, so now I'm definitely going to put in parentheses 3.25 times 10 to the 21st divided by, and then in parentheses again, 6.022 times 10 to the 23rd, and that's going to equal 0.0054 moles of water. Now, I will say mole numbers are usually going to be small decimal looking numbers. They're not, you shouldn't be receiving like 200 moles of something or anything that needs to be in a large scientific notation like 6 times 10 to the 8th moles. That's too big. That means you probably messed up somewhere, or maybe you got your Avogadro's number upside down, like your conversion factor. You chose this blue option instead of this black option where it's on top, okay? So that's a common mistake. So let's get more steps. Actually, I'm going to change colors here. We're going to more steps. Those were one-step conversions. Let's pretend you're given grams, that's a G, and the question mark is molecules. Okay? So same deal. 13, let's just pretend 13.84 grams of water again. Now we have 2 steps. We're going grams to moles to molecules. Okay? 18 grams, that's an 8. 18 grams of water in 1 mole of water. And then I know, all right, grams cancels. Moles, I must have moles down here. Moles of H2O, Avogadro's number. Molecules. 1 goes down there, so that cancels with that, leaving me with, all right, what is that, 13? Show us all these. 4.63 times 10 to the 23rd molecules of H2O. Okay? Same thing here. What if you were given in nanograms of water? You go nanograms to grams, and then to moles, and then to molecules. Okay? Same kind of process. We're going to do one more. I don't know what other colors I have. Let's do red, because this one's hard. So let's do, given 12 grams of, and I'll pick an ionic substance, so we'll be doing a different unit than molecules here, of magnesium nitrate, okay? The question mark is, how many oxygen atoms are present? So this would be important in medicine if you had a drug. This is kind of like finding the active ingredient. You know, if you buy a substance and it's like 90% active ingredient and 10% something else, I want to know how many oxygen atoms are present in this entire substance. Okay? So we're going to go from grams of the whole thing. So grams, I'm going to put grams of all, the whole thing, just for simplicity's sake, to moles of all. And then, and I'll even change color here so it's super clear, moles of O. I got to convert to moles of O before I can then go to molecules of O. Okay? So I made that in green, so it's a special step here. All right. 12 grams of magnesium nitrate. See if, I don't even know if I'm going to be able to fit all this in. I did compute the molar mass of that. Write out the whole thing. So I'm getting into moles. If you're not given moles, you better get it into moles. because moles is our MVP. We got to get to moles before we can go in either direction, whether we're going from molecules back to grams or grams to molecules in this case. Back to green here. All right. How do I know the relationship of magnesium nitrate to oxygen? That 6 came from the fact that I multiplied this 3 times this 2. There are 6 oxygens present in that whole thing. So this O here is short for oxygen, not like 0. Short for oxygen. Okay? So grams of the whole thing has canceled. Moles of the whole thing have canceled, leaving me now with the unit of just oxygen. And now I can use 1 mole of O, 6.022 times 10 to the 23rd atoms. So we're atoms of O, okay? Because remember, that was one of the choices way up here. Atoms was one of the choices for Avogadro's number. Okay. So, I actually didn't do that math. I wrote it all out, didn't do it. So in my calculator, I'm punching in 12 times 6 times, and then in parentheses 6.022, second E, 23. And then I'm going to hit divided by 148.3. So like I have an answer and then I hit enter, divided by, and that should give me 2.92 times 10 to the 23rd atoms of oxygen. Okay, that is a big multi-step, but it is important to keep this in mind. Okay, I think we'll stop there on conversions.